All right, so honors geometry, I want to do one of the proofs with you as well. So here's the proof. Given that segment BE bisects angle DBC and that segments BE are parallel to segment AC, prove that segment AB is congruent to segment BC. So just to kind of talk about isosceles triangle theorem. So this right here, prove that AB and BC are congruent. This means that we got to prove that this is an isosceles triangle. And the way that we do that is by showing that these two angles are congruent. So somehow this is my goal, to say that angle A and angle C are congruent. If they're congruent, then segment AB and segment BC are going to be congruent. And it's actually the converse to the isosceles triangle theorem, but I'm not sure if they're going to care that much about the whole converse idea. Okay. All right, so again, that's my big goal. So what can I do up to then? Well, if I use the fact that BE, right, BE bisects DBC, I know that these two angles are congruent. Angle DBE and angle CBE are congruent. That's what I'm going to say. So type statement, congruent angles. Angle DBE is congruent to CBE, and that's by the definition of an angle bisector, right? If an angle bisector divides an angle into two congruent angles. Boom. Good. Okay. Now, what about the parallel lines idea, right? Well, if I know that BE is parallel to AC, do I know an angle is congruent to this angle? Well, yes, I do. This angle is, in terms of the transversal, it's in the top right of this intersection. If you slide down this transversal, so is angle A in the top right. These two angles are congruent. Angle DBE is congruent to angle A, and that's because they're corresponding angles. DBE is congruent to angle A. That's because they're corresponding angles. So if we have parallel lines cut by a transversal, corresponding angles are congruent. Nice. Okay, now what about these angles here? I'll do them in purple. What about this angle? Well, again, parallel lines, parallel lines. Here's your transversal. Do you see the Z? This angle is going to be congruent. This angle right here is going to be congruent to this angle. So angle CBE is congruent to angle C. And that's because they are alternate interior angles. I'm sorry, I called it CBE. CBE up above, angle CBE is congruent to angle C. And again, if lines are parallel, you have the alternate interior angles that are congruent. Nice. So now look, I have these three statements. So DBE can be replaced with A, CBE can be replaced with C. I wonder if we can do one big long transitive property. I'm not sure how they're going to let me do it, but I have what I want to have. Okay? I can say that angle A and C are congruent now. So let's see if I can do that all at once. Angle A is congruent to angle C. And again, just one big long transitive property. I'm trying it. They let me. Because again, angle A is congruent to DBE, which goes here. Angle C is congruent to CBE, which goes here. So A and C are congruent. And now, because angle A and angle C are congruent, yes, I know that segments AB and BC are congruent. I know that segment AB and BC are congruent because of the isosceles triangle theorem. In a triangle, sides opposite congruent angles are congruent. That's the isosceles triangle theorem. Boom. Green check mark. Submit that. Oh yeah, love me some green check mark. And again, I hope it's about the same. Yep, very similar. Cool beans. All right, so there's your proofs. Good luck on these other isosceles triangle